recording on this computer. Here we go. We're going to finish the direct variation assignment. Now, we talked about lots of things in the last video, so please, please, please watch the last video if you're confused by anything I'm talking about. I'm going to put that up here. I'm going to put this guy up here too. Wait, let's make sure that I'm sharing the right thing before I record an entire thing and don't share what I'm doing. Okay, so we were on the dashboard. We talked about the assignment in algebra. You can see everyone's doing things in Inquire, and that's wonderful, but that's not what we're doing right now. We are going to finish our assignment. So we're opening up our recent thing, which was direct variation. There it is. And there were a lot of things we did not get to. I believe we stopped at 16. So I'm going to erase 16. We're going to go from 16 to the end. I might have talked about it a tiny bit last time, but we might as well start from scratch with this one problem. Okay, so, oh my gosh, I just had it right there. Such a weirdo. Okay, that's fine. Here we are. 10 does not equal 35, that's for sure. And that's it. That's it. Okay, great. So 16 cups of sugar to make cookies. It takes 1 cup of sugar to make 3 dozen cookies in this particular recipe. That seems like not a lot of sugar, but I'm not a baker. Who knows? We're supposed to write a direct variation equation in 2 variables that represents this situation. Now, you may be tempted to write a proportion, and that would be fine. I could say 3 cookies, 1 cup of sugar. Honestly, which depends on which is hard to tell. I can't tell. Perhaps the number of cookies you can make depends on how much sugar you have, or perhaps the amount of sugar you use depends on how many cookies you bake. It doesn't really matter. So we're going to set it up that way. You know what? I am going to share this on the other screen because I keep looking down at unshare. I have this horrific idea that perhaps if I share the other screen there, it won't show. And I would make it a long tape and it wouldn't be there. Okay, so now, so you could say 3 cups, 3 dozen cookies made with 1 cup of sugar, right? And then they're going to ask me, what about 10 cups of sugar, right? So you could say, or 10 dozen cookies. So I could say 3 dozen. You know what? I'm just going to take the D away because it looks like a variable, but that's actually supposed to be dozen, right? And cups, whatever. Okay, so 3 over 1 is my ratio. In other words, for every 1 cup of sugar, I make 3 dozen cookies. Okay, however, what if I have 10 dozen cookies? Now you'll notice, usually it gets like 2 times bigger, 3 times bigger. This does not. This gets something awkwardly. This is like 10/3 bigger, 3/10 or something. Who knows? It's some weird decimal. You can't go from 3 to 10 evenly. And so we needed another strategy. You could do the cross multiplication thing and it would work. But it's asking me to write a direct variation equation. So I'm going to use that lovely direct variation formula. Remember, the direct variation formula is y equals kx. Y equals k times x. And to find to find k, you could say y divided by x equals k. All right, those are the same formula. That's direct variation formula. Okay, or format, or whatever you want to call it. I guess we're going to say formula because it sounds right. Okay, so we're going to use that. So I'm going to say one of these is cups and one of these is sugar. So I'm going to say let y be cups of sugar and x be dozens of cookies. So Now when we go over to this thing, we're going to replace its sugar equals K times dozens of cookies. Now the way that direct variation works is it sets this up as an equation like that. We don't know what number K is, but we do know that the sugar is 1 cup. And we know that the cookies is 3 dozen. So that's 3, K times 3. I'm going to switch the order they're in. 3 times K is the same as K times 3. We just like to write the number first in this world of mathematics. Okay, so now I'm going to divide both sides by 3, like this. Oops, that was not great. So, okay, going back to here. If I divide both sides by 3, the reason I'm going to do that is because 3 is with the K, and I want the K to be by itself. I want it to look like this. And basically, all I'm doing is doing the step that turns from the left side to the right one here. So if I divide both sides by 3, then I get, well, these guys cancel out like so. And I get 1 over 3 equals K. K, or 1/3, equals K. Okay, so now I know that my constant of proportionality, K, my ratio, like we had 1/28 earlier, it's 1/3. That's the way we do it using the official formula for direct variation. But there are other ways you could get the same answer. Okay, but what does this mean? This means that there's 1/3 as much sugar as there are dozens of cookies. That's what that means. Okay, great. So what's that mean then? Use your equation to solve the equation here. Okay, so here's the cool thing. When I want to solve it, I can use that formula over and over. So y equals kx, right? Which is sugar, kx, which is sugar, equals K times cookies, just like above. But the different thing is, now I know what K is, and I can use it to find other things. It's like my slope. Okay, so now I know that sugar equals 1/3 of the number of cookies, which is what we figured out. Okay, so now they ask, what if I had 10 dozen cookies? Well, I'd have to have the sugar equals 1/3. I'm going to put the 1/3 in parentheses because it makes it more obvious that I'm multiplying by the 1 and not the number of cookies. This is a very important thing, and it's an easy mistake people make. If I have 2/3 times 5, remember 5 always multiplies by the top, and I get 10/3. Why is that important? Well, it's much more easy to see when the fractions are written this way, but when they're written like this, it's really easy to be like, oh, I have to multiply 3 times 10 and get 30. No, 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 no. You multiply the number by the top of the fraction every time. So let's multiply by the top of the fraction, and we will get, what will we get? We'll get 10 divided by 3. Sugar equals 1 times 10 is 10 divided by 3. And what does that mean? Sugar equals, well, 3 goes 3 times into 10 and 1/3, so like 3.333, or 3 and 1/3 cups of sugar. So we figured out if I want to make 10 batches of cookies, 10 dozen cookies, I guess, then we need 3 and 1/3 cups of sugar, assuming that 1 cup makes 3 dozen cookies. And so we figured it out. Now, if you're a real baker, you'll say, well, it's not exactly proportional. You're right. Almost nothing in life really is. Things are a little more inexact than that, but there you go. The number of drops of paint needed to paint something purple. Purple paint, they put drops of dye in the paint. I don't know if you've gone to Home Depot, it's really fun. They put a couple drops of color in, and they shake it around, and suddenly you have paint that's no longer white. And the more paint there is, the more dye you need to make it that color. So we notice that 5 drops of tint are mixed with 2 gallons of paint to create the correct shade of purple. However, what if we had 6 gallons of paint? Now this is one where it would be much easier to do it as a proportion, because we have drops and paint. Now, does the amount of paint depend on how many drops I use, or does the amount of drops of dye depend on how much paint they're putting it in? The drops depends on the paint, right? And remember, dependent goes on top. So I'm going to put drops. Oops. I'm going to put drops over paint. Okay, because drops depends on paint. This is my independent on bottom and dependent on top always. Okay, so what does that mean? I'm going to put 5 drops. Well, I'm not going to say equals. I'm actually going to put an arrow saying if I have 5 drops, then I need 2 gallons of paint goes with that, right? And I'm going to make a fraction. I need to make another fraction with 6 gallons of paint. The only question is to ask, does the 6 go on the bottom or the top? Top or the bottom? And the answer is, think about it, answer, and here we go. The bottom is paint. The bottom is paint. The bottom should be the paint. You just be consistent and it works. And they want to know how many drops. So let's make it D for drops, or you could make it T for tint, or you could make it X because this is an algebra class. Whatever you like. D. Okay, my D is ridiculous looking in this because I'm writing with a mouse. And now we can just say this gets 3 times bigger. So guess what? That's also going to get 3 times bigger. Times 3. I will tell you at least half of proportion problems can be solved this way, to go like, oh, that gets this many times bigger. So that has to get the same number of times bigger. So that means D must be 15. That is almost always the fastest way to solve something. This type of proportion. Make the fraction, make the new fraction, put a letter where we don't know something, and figure out how many times the other number gets bigger or smaller. And then we can compare it and figure it out. So we need 15 drops to dye 6 gallons of paint. And that's how we do it. Pretty easy, right? So easy. Okay, how about this one? Think about it. We got Sandra was hired as a part-time office assistant. The amount of money she earns in a week is proportional to the number of hours she works during the week. She earned this many dollars working for that many hours. So we have one fact right there during her first week on the job. During the second week, she worked 35 hours and made that much money. Now they gave us more information than we need right there, because they're saying it's proportional, right? So they're saying that these 2 things should make the same fraction as those 2 things. Do I need all 4 of them? No. I can make a fraction of the first ones or the second ones. It doesn't matter which ones, they should make the same fraction, because that's what proportional means. So I could make a fraction with the 20. Let's see. The money depends on how many hours you work. So I could make a fraction like 167. That money depends on how many hours she works, 20. And I could also make a fraction with 292, 25 over 35. That seems like a lot of work. I'm not going to use this one because I'm lazy. Okay, I'm going to use this one. This one's much nicer. The last thing I can ask myself is, does anything go into there? Can I simplify it in some way? Now, I will tell you, since this is a regular number, if this was a regular number, this would not be a simplifiable fraction. 167, the only things that go into 20 are 4 and 5. And I guarantee you, 4 and 5 don't go into 167. So it's simplified, right? But then again, this is money. And in money, we go to 2 decimal places. So we might as well go to 2 decimal places. So I'm going to say, what if I had 10 of these? Instead of 167, it would be half that much, right? 10 hours, she should make half as much as that, which half of 160 is 80, and half of 7 is 350. So it should be 8350. Now I can even go further. I can divide by 10, right? So she makes $10 in 83.50 in 10 hours, and in 1 hour, she'll make $8.35. How did I do that? Well, if I divide by 10, if I make this 10, 1/10 as big, I made that 1/10 as big. And remember, if I make something 1/10 as big, it moves the decimal point over one spot. That's something you learned at some point in mathematics. So we figured she makes $8.35. $835, $800.35 per hour. I will tell you, my friends, don't take a job that pays you $8.35 because I believe it's illegal in Washington. That is nothing. That is a very small amount of money. Okay, Sandra worked for 28 hours during the 3rd week. How much should she earn? Okay, so if she worked 28 hours, well, now we've got something really easy. I'm going to write it as a proportion. But you know, if she makes that many per hour, I just multiply that by 20, right? Or 28. Well, how does that look with this whole proportion thing? So I got 8/35 equal over 1 equals x over 20, because I know 28, because I know she worked 28 hours. This gets 28 times bigger, and yup, that also has to get 28 times bigger. So using this proportion thing, it works the same way as your brain. It's like, oh, to get 28 hours, I have to pay this much 28 times. So 835 times 20, 835 times 20 is $167. She will make $167. Wow, living big. That is such a small amount of money, my friends. Again, not a good idea. Okay, create a graph showing how much Sandra will earn working 5, 10, 15, 20, and 25 hours per week. Okay, let's do this. So remember, the money she earns depends on the hours. Money depends on hours of work. So we put hours of work down there. I'm going to put a 0. Let's see, we needed to do 5, 10, 25. We need to go up to 25 hours per week. So 5, 10, 15, 20, 25. I think that's going to be the best thing about this. I'm just trying to spread it out nicely. 5, 10, 15, 20, 25, 30, etc. Right? We only need to go up to 25. If I counted by 3s, maybe that would work too, but this is fine. I just need to make sure that it has these numbers because that's what I'm going to check, right? And then we need to make money. Well, 28 would make $167, right? So we need to have numbers less than that because this is if she works 28 hours. And all of these things are under 28 hours. So she can't possibly make $167. I'm going to go up to, oh, I don't know, 160-ish. Let's see where this goes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So if I want to go up to about 150, 160, let's see. We'll just go with 10 each. 10, 20, 30, 40, 50. It'll be close. 25 might go over the top, but all the rest should fit. 10, 20, 30, 40, 100. $150. Okay. So now we have money that she's making up to $150. Okay. So if she works no hours, how much money will she make? That's easy. She makes no hours. If she works no time, she makes no money. It goes through 0, 0. Okay, what if she works 5 hours? Well, we found out she makes $8.50 an hour. It's 35 cents an hour, so 8.35 times 5. 41.75. Okay, let's go over 41.75. 5 hours, 41.75. That's just over 40. 10, 20, 30, 40, just over 40. 41.75. Great. Okay, what if she makes $10? Let's see, what about $10? 10, well, I know what that is. That's going to be $83.50. We did that. That was one of our solutions up here. $83.50 for 10 hours. All right, so 10 hours, 60, 70, 80, $3.50. There. All right. 15 hours. Well, 15 hours is going to be these added up, actually. Right? So I could add them, or I can just say 15 times 8.35. Probably faster. 125.25. Okay. 125.25. 125.25. Uh-oh. We are going to go off the graph, aren't we? We're 20 and 25. That's interesting to me. Did I make a mistake with the last problem? Did I multiply by 20? I did. 8.35 times 28 is 233.80. This is wrong. I multiplied by the wrong number here. I multiplied by 20. I apologize. So my graph's going to go off the graph. That's what tipped me off to it. I was like, wait a second. That's going too steep. It's going to go off the graph. It's not supposed to. I planned it better. 233.80. Okay, so this is 233.80. That's how much money she'll make. And I need to change this thing. I'm actually just going to erase it, because I don't want to write it again. Okay, so that means that this graph goes on. But you know what? It's a pretty good graph. And I'm not going to take the time to fix it. You don't have to if you don't want either. Okay, Jacob has been working a part-time assistant. He starts off the same pay as Sandra. After 6 months of quality work, he's earned a 50-cent per hour raise. Man, this is a stingy book, my friends, but that's okay. Okay, so, well, I guess for 6 months, 50 cents could be all right. Okay, identify the constant of proportionality in his situation. Okay, that's complicated because oh, Sandra's up here. That's right. Here's Sandra. She makes 8.35, right? Identify the constant of proportionality from Jacob's situation. Okay, so we're going to assume that he's gotten the 50 cents an hour. So instead of 8.35, he makes 50 cents more. 8.85 per hour. So that's right there is our constant of proportionality. See how it's per 1 hour? You could say per 1 hour. And dollars if you wanted. It's $8.85 per 1 hour. So there is a number there, but no one ever bothers to write the number. They just write 85 per hour. You can put the money there. Okay, How much will he earn at a 22-hour week? Well, he'll earn 85 times 22. That's how much he'll make, $194. Which is 22. Oops. So you understand. What I just did. We're saying 8.85 over 1, well, times 22, right? And we could do it the same way as the last one, but it just gets tiring to write the same thing over and over. Like this gets 22 times bigger, that gets 22 times bigger, and we have that right there. It's the same thing. $194. Okay, so now this one, 22 weeks, 194, we need to go a little past 200. This time I'll pick something that works. There are 15 of these. We want to go to fifth, let's see, 300. We'll go to 300. So this is 20, 40, 60, 80, 100. I'm counting by 20s, 20, 40, 60, 80, 200. 20, 40, 60, 80, 300. All right, that's nice. We could count by something else if we wanted, but it's just what it is. You know, if you really wanted to be fancy, you could count by factors of 85, and you'd have all of these weird decimal numbers here, but everything would line up nice. 0. We need to go up to 5, 10, 15, 20, 25, 5, 10, 15, whoops, 10 is right here. 15, 20, 25, 30. I might as well write 35. This one might actually stay on all the way. We'll see. Okay, so we have that 5 hours at the rate of 8.85. 5 times 8.85 makes 44.25. 44.25. Yep. Okay, 44.25. Let's find it. 5, 20, 40. 44.25 is going to be about there. Remember, these lines are each 20, 40, 60, 80. They're each 20. So this is 40 and a little bit more. Okay, for 10, it's going to be twice that much. So 88 something, right? 88.50. Because he worked twice as long, you should make twice as much. 88.50. That's close to 90, just a little bit less than halfway up here. All right, 15. Well, one thing I can notice is this goes up a line and a little bit more, up 2 lines and a little bit more, 2 lines and a little bit more. 1, 2, and a little bit more. It's going to be somewhere like here or something. Wait, I'm in the wrong spot. Here or something. Let's see. Let's see, that's about 120, 30 something, right? Let's see if that works. 15 times 8.85. 130 something, look at that. So you can see, I can trust the graph a little bit. It seems to be going nicely through all of these points. So what I'm going to do is, oh, I just went off the screen, so it freaked out. Z, Z, Z. Remember, if I hold Shift, I can make a line that does this. And there we go. That's about the line. So if I work 30 hours, I should make 220, 40, 60 something, just over 260. And there we are. Okay. Yeah, I can show the whole screen if you like. Oh, I forgot to label money. And hours worked. It is important to label your graphs. David works at a tile decorator for ceramic factory. We did that, remember that? Tile decorator. The amount of money he earns is directly proportional to the number of tiles he paints. When he paints 15 tiles, he gets 41.25. When he paints 25 tiles, he earns 68.75. Wow. You better not spend too much time on these tiles, is all I have to say. Identify the constant of proportionality. Okay, so again, it gave me the information. It's right there. It's right there. My two variables are money and tiles. He gets paid a certain amount per tile. That's what we're trying to figure out. So we're going to do that. And the money he makes depends on how many tiles he does. So we're going to put the money on top of our fraction and the tiles on the bottom, the number of tiles he creates. Okay, so how much money? Which one do I want to pick? 25. Let's do the bigger one this time, just for fun. 25 tiles. Well, the 25 tiles, that goes on the bottom. And 68.75, that goes on the top. So I'm going to do 68.75, 68.75 divided by 25. Oof. Well, what am I going to do here? Can I simplify this one? I could find out. What if I made everything 1/25 as big? Let's find out. 68.75, 68.75 divided by 25. What does it make? Whoa, that's not right. It doesn't make 25, that's for sure. 68.75 divided by 25. Try that again. 275. Look at that. 275. Okay. So I divide these. This equals 275 dollars for one tile. Oops, I want to push enter. For one tile. So we figured out if this gets 1/25 as big, and that gets 1/25 as big, then I get a certain price per tile. I did it by dividing by 25. Okay, so that's my constant of proportionality. He makes 275 per tile. How many tiles did David paint if he earned $99? Well, I got this right here. That's what I use every time. 275, if you're stumped, you're going to multiply or divide. And if you can figure that out, then you can do this really fast. But it's good to practice this whole tile to use this practice. He's going to make $99. That's the top, right? That's the money side. That's the top of the fraction. So that's $99. And the question is, how many tiles? Okay, well, what's going on here? Well, I have to figure out how many times bigger it's getting somehow. Now, if I have trouble with that, I can use the other method. I can say, well, I'm not sure how many times bigger 99 is than 25. I can divide to find that out, and that's what I would do. I would divide 99 by 275. But we're going to do that by cross multiplying. So we'll call this x, by the way. X tiles. Okay. Okay, so I'm going to take 275 times x. 275 times x should equal 1 times 99. Well, 1 times 99 is just 99, just to be completely clear. I'm going to scoot this over a little bit further so it lines up. So now I just have to get rid of the 250 so I know how many tiles we're going to use, because X is the number of tiles. I will actually just change that to an X in real life. X there. Okay, so if I want to get rid of the 275 so I know how many tiles alone, I have to isolate the X. And I can divide by what's going on to X is being multiplied by 275. So I'm going to do the opposite. I'm going to divide by 275. If I do the same thing to both sides, I'm going to get 99 divided by 275 equals X, which is what we were going to do earlier anyway. So why is this useful? This is just good practice, because there are problems later in math that will stump even the best of you. Equals 99 divided by 275. Let's figure it out. 99 divided by 275. 36. There you go. 36. So what does that mean? X equals 36. David, well, X was the number of tiles he has to make to get $99. So 36 tiles to make $99. That's great, right? Oops, 36. I typed 35, I said 36. Okay, we're gonna make a graph, and then we're to the last page. Create a graph showing how much David can earn while painting 0, 4, 8, 12, and 16 tiles. Now we know that 36 will get him up to 100. We know that 25 will get him 68, 15, what are we going up to? We're going up to 16. So we'll go with the 15 tiles gets him about $41. So we'll go up somewhere past 41, like 45 or something. Something a little bit more than 41 on here for our money. And over here we've got our tiles decorated. All right. So here's how many tiles he decorates. We don't, well, we know how many. We just want to go up to 16, right? So 2, 4, 6, 8, 10, 12, 14. Nope. 2, 4, no. Yep. 2, 4, 6, 8, 10, 12, 14, 16. That's frustrating. 2, Yep, we got to go by twos, and that's okay. Can't count by ones because we won't get up to 16. Etc. I don't need to go further. I only need to go up to 16 anyway. And the money he's going to make goes up to, we said, if he makes 15 tiles, it's going to go up to 41. So we need to go past 41 because he's going to make up to 16 tiles in this situation, up to 16 tiles. So he's going to make it more than $41. So what should this count up by? 5, 10, 15, 20, 25, 30, 35, 40. That's a little too fast. I counted by fours. Twos. Let's see, there are 15 of these, right? Twos should work. No, twos will only go up to 30. So I'm going to count by fours. That'll go up to 60 or so, which is great. 4, 8, 12, 16, 20. Now notice I just count by the 4, 8, 12, 16, 21. Oh, come on. What are you doing, computer? 4, 8, 10, 12. Wow, it won't, there it was. Huh, 40, strange. 4, 8, 12, 16, 20. There we are. And 4, 8, 10, 12, 16, 20. Look at that, goes up to 60. Not bad. All right, so let's graph some things now. For 2, what do we need to do? We need to do 4, 8, 12, and 16. 4 is my first one, so for 4 tiles, well, if it gets paid $2.75 per tile, that's $2.75 times the 4 tiles that he makes. He makes $11. It seems like a great deal, doesn't it? 4 tiles is $11, so that's 4, 8. This is 12, so 11 is going to be right there. Okay, for 6 tiles, no, 8 tiles is next. Well, $11, he's going to double that, right? It works 8, so he's going to make $22. $22 is right there. All right. And for, let's see, 12, well, that's going to be 11 plus 22 is 33. 24, 28, 32, 33. All right. For 16, well, that's going to be twice as much as 8. This was 22, so this is 44. Notice it's just going up by 11s because that's how much he makes every 4 tiles. So 44 is going to be right there. And then 16, no, that's what the last one we did. Great. Hey, those guys line up pretty well, don't they? Good job guessing, Joel. All right, so that's that. Let me get rid of that blood stain. Okay, here we are. Now we're going to solve the proportion. I'm going to say, if you can, say 16 turns to 14 by doubling or tripling or quadrupling, that's fine. But generally speaking, we cross multiply like this. So I get 4 times 14 equals x times 16. That is a useful trick. 4. No, x times 16, which is 16x, equals 4 times 14. 4 times 14 is 40 plus 24 is 64. So that's 16x equals 64. And now I just have to divide both sides by 16. Or I can notice, what do I multiply by 16 to make 64? Seems like I should know that. Well, you might know that. But I'm going to divide both sides by 16 because right now x is being multiplied by 16. So I divide to do the opposite. You always do the opposite of what's happening to x. And notice this guy goes away. So I'm left with just x. Now, what does that mean? Well, on the right side, I have to, divide 64 by 16. So x is whatever 64 divided by 16 is. Let's put it in our calculator. Look at that, it's 4. X is 4. I just figured out the answer. These steps will work every time. I cross multiply. I divide to get rid of the x. What's next to the x? Every single time. So if I cross multiply this one, now I do want you to know this one we could figure out because I know what I multiply by 5 to get 30. I can know what this is. So this is 1/6 as big as 30. So this has to be 1/6 as big as 12. So I know already x is 1/6 of 12, which is 2. So if you're doing it that way, great. That saves you a lot of time. However, we're also going to cross multiply because it's good practice. Cross multiply. You got skills. There, multiply. And so we got 30x equals 12 times 5. That's 30x equals 12 times 5 is 60. What do I multiply by 30 to make 60? 2. So x must be 2 if you multiply it by 30 to get 60. And that's true. X equals 2. If I divide both sides by 30, then I get that. Okay, that's it. We made it. I might as well show the process of the division because that's my job. So I divide this side by 30 and this side by 30. And then I have, boom, 30, 30. And I can put that back because when I divide the left side by 30, the 30s go away and I'm left with just x. If I divide the right side by 30, I get 2. And there we got it. Have a wonderful, wonderful winter break.